Hello, in this video we're going to be reviewing and doing some examples of the concept of productivity. We'll work through a number of questions just to show you the types of questions you might be asked relative to productivity. But before we do, let's just quickly remind ourselves what productivity is. So productivity, it's a measure of efficiency. It tells us how well we are converting factors of production into output. So in this circumstance, calculating productivity is output over input. So you get a measure of productivity that is units of output per unit of input. And the unit of input can be physical measures or it can be dollars. And we'll talk later about what the relative, about when you would use which. There are multiple things we can do. There is single factor productivity, which uses individual factors of productions like labor, raw materials, management. And so this, the single factor productivity measures look at your ability to transform sort of specific things into output. And then finally, we'll look at multi-factor productivity, which assesses the degree or the efficiency with which you put a combination, either all factors of production or some subset of those factors, into output. So those are the basic concepts. I would refer you back to my introduction to productivity video, which sort of gave an overview. This video will focus on a number of questions to highlight the execution of these types of problems and the kinds of questions you could get. So here's the first one. Susan produces seasonal wooden yard ornaments for resale at a local craft fair. She currently works 8 hours per day to produce 16 ornaments. Part A, what is her productivity? Part B, she thinks that by redesigning the ornaments and switching the type of glue she uses, she can increase production to 20 ornaments. What is her new productivity? And C, what is her percentage increase in productivity? And that assumes that productivity will go up. So let's look at each part of that question individually here. So, for part A, output is equal to 16 ornaments per day. Input is equal to 8 hours per day. This question just asked for her productivity, and it only gave you labor as an input. So we are going to, in this circumstance, calculate labor productivity. If it had told us how much wood she used or other factors, we could have done other productivities. But in this case, we're just doing the labor productivity because that's the input we are given. And we weren't given how much she charges herself for her labor, so we're going to do it in hours. There are circumstances where it makes more sense to do it in dollars, and we will talk about that shortly. So her labor productivity is equal to output over input is equal to 16 over 8 equals 2 ornaments per hour. So her labor productivity is 2 ornaments per hour. That is the efficiency with which she produces ornaments using her own labor. So let's look at part B, where output changed to 20 ornaments per day, and input stayed the same. So her labor productivity in this circumstance is equal to 20 over 8 is equal to 2.5 ornaments per hour. So one of the things that I would highlight here is that this was 2 and this is now 2.5. That means output relative to inputs is increasing. So a higher productivity number is always better than a lower productivity number. And that's one mistake that students always make in interpreting these. Sometimes we want a lower number, sometimes we want a higher number, but in productivity, the higher number is good because it is more units of output per unit of input. So then let's look at percentage increase in productivity. Percentage change is equal to new minus old divided by old. This is a mistake that students frequently make. You make the percentage change from your starting point, and that's how you calculate it. And that would be equal to 2.5 minus 2 divided by 2 is equal to 0.25, or 25% increase in productivity given the change that she made. So first question, relatively straightforward, and we calculated output over input and calculated labor productivity. Let's look at a second question here. Very similar. A firm cleans tank cars with standard equipment. The firm typically cleans 70 cars per month. They use 10 liters of solvent and 2 employees work 20 days per month at 8 hours per day. The company switched to a bigger cleaning machine. Last month they cleaned 60 cars in only 15 days. They used 12 liters of solvent and 2 employees worked 6 hours a day. What is the labor and raw material productivity to start? What is the labor and raw material productivity afterwards? And what is the percentage change in both? So again, relatively straightforward question. So with the original equipment, output was equal to 70 tank cars. Solvent, 10 liters. Labor, and this is one where we have to be a little bit thoughtful about how we do it here. We could just use employee days, but because we are aware that the employees worked fewer hours per day in the second case, and we want to compare the two, we should do it in hours of input and not days of input. And so the second really important key on productivity is to make sure units are consistent. That's the only way you can make sure that your comparisons are accurate. So in this circumstance, we're going to do 20 days times 2 employees times 8 hours per day equals 320 hours. So for these 70 tank cars, we did 320 hours. So solvent productivity is equal to 70 over 10 is equal to 7 cars per liter, and labor is equal to 70 over 320 equals 0.22 cars per hour. So again, we've calculated output over input for 2 different inputs. In part B, output is equal to 60 cars over the period we measured. Solvent is equal to 12 liters. And labor is equal to 15 days times 2 employees times 6 hours per day. And then this highlights that we have to do hours and not days because of the number of hours they worked per day. They were assigned to other tasks likely on the rest of the time is 180 hours. So then our solvent productivity is equal to 60 over 12 is equal to 5 cars per liter. That's actually gone down. With the new machine, we're using more solvent per car, so our productivity has actually gone down, but our labor productivity is equal to 60 over 180 is equal to 0.33 cars per hour. So our labor productivity has gone up. Now, we cannot definitively say that one is better than the other because we don't know of the relative cost. We know we've gotten less productive on solvent and more productive on labor. And so if we wanted to do a more direct comparison, we could look at dollars, or more importantly, we could look at multifactor productivity, which we will do in the next question. But the last part of this question was, what was the percentage change? And we'll do that quickly. But I don't think I wrote this down, but let's do it anyway. Solvent percent change, percent delta is equal to 5 minus 7 over 7 equals negative 28.6%. Labor percent delta is equal to 0.33 minus 0.22 divided by 0.22 is equal to a 50% increase. So again, we can't say 50% is better than down 28.6%. We just know we've gotten more productive on labor, less productive on solvent. We can look at the relative cost if we want, but in this circumstance, maybe a multi-factor productivity calculation would be a better choice. So let's look at, we have 2 questions left. Question 3, a firm makes ceramic vases for a chain of department stores. The output and cost figures are below. Labor costs $20 per hour and material costs $8 per kilogram. We have output in week 1, 2,000, week 2, 4,000, week 3, 5,000, week 4, 7,000. So we're seeing production ramp up. Number of workers, 4, 4, 5, 6. Hours per week also goes up, 40, 48, 56, 70, which tells you that as units of input, we can't use individual numbers of workers because they're also working different hours per week per worker. And so we have to convert to hours. That just highlighting there that we need to think about units. And the kilograms of material, 128, 256, 324, and 450. And the questions are: calculate labor productivity for each week, calculate raw material productivity for each week, calculate the multi-factor productivity for each week. So let's proceed through those questions. Part A. We are going to do labor productivity in units per hour. We could do units per labor hour, or sorry, per labor dollar. But because we are comparing across consistent labor rates, it's the same. So if labor or wage rates had changed, we might want to do it or if we're comparing between locations, as we will in the next question, we might want to think about labor dollars, but in this circumstance, we're just doing, hours. So labor productivity 1 is equal to 2,000 divided by 4 times 40 is equal to 12.5 vases per hour. This was 4 workers who worked 40 hours per week, and this was the output in week 1. Labor productivity in 2 is equal to 4,000, which was our output. We had 4 workers, but they worked more hours. So our output went up much quicker than our labor hours did, so our productivity went up quite substantially as well. LP3 is 5,000 divided by 5 times 56 is equal to 17.86 vases per hour. So our productivity has come down again. LP4 is equal to 7,000 divided by 6 times 70 is equal to 16.67 vases per hour. So we've seen productivity go up dramatically to 20.83. We then saw it come down. I would argue that these two are within the same range of each other. I think it's worth noting here that significant variability in labor productivity may warrant some attention. So it could be that as we're working more hours per week, the workers are tired and become less productive. We're adding workers. The new workers might not be as productive because they're not trained up as much as the original 4. All of those things, all the productivity measures that can tell us is that something has changed. It is this up and down. We may want to investigate the cause. So one of the reasons we will do productivity measures is to highlight this variability. If it happens, it gives us a hint that perhaps we should go look at what's happening. That's one of the reasons we might do productivity measures. So looking at it, we can tell it went up, went down. Worth investigating why that change occurred. There is some natural variation that will occur, but in this case it seemed quite dramatic. So the second part of the question is the material productivity. Again, we're going to do it in units per kg because there was no change in the cost of the raw materials, but we could have done it in terms of raw material dollars as well if we wanted to. So material productivity 1 is equal to 2,000 divided by 128 kilos is equal to 15.625. MP2 is equal to 4,000 divided by 256 is equal to 15.625. Identical. MP3 is equal to 5,000 divided by 324 is equal to 15.432, which is down marginally, but I would argue is within the reasonable range of variation. And MP4 is equal to 7,000 divided by 450 is equal to 12.56. Or sorry, 15.56. So all of these are within the same. So what isn't changing is the amount of output per unit of input. The amount of output per unit of labor is changing dramatically. It could be how hard they're working. It could be new employees. It could be a variety of things. It merits some attention. But that's one of the ways that you might use productivity measures. So let's now do the part C of this question, which was multi-factor productivity. So in this case, multi-factor productivity for week 1 is equal to output, 2,000 vases, divided by $20 per hour times 4 workers times 40 hours, which is the labor component, plus $8 per kg times 128 kgs, all in dollars. We need consistent units. It's critically important that we don't add labor hours to kgs and try and do multi-factor productivity. It is inconsistent units in dollars. So this is equal to 0.47 vases per dollar. And then we would do the same thing. 4,000 divided by 20 times 4 times 48 plus 8 times 256 is equal to 0.68 vases per dollar. $20 per hour, 5 workers times 56 hours, 324 equals 0.61 vases per dollar. And multi-factor productivity 4 is equal to 7,000 vases divided by $20 times 6 workers times 70 hours plus $8 times 450 kilograms is equal to 0.58 vases per dollar. So in this circumstance, we see a similar pattern to the labor productivity in the multi-factor productivity, driven by the fact that we had variability in labor, but this gives us a broader value in terms of dollars spent and the output produced. The last question is one that many organizations face, and let's take a look at it. Suppose workers in Mexico earn 132 pesos per hour. The exchange rate with Canada is 16.5 pesos per dollar. Canadian workers produce 60 units per hour, while Mexican workers produce 332 units per hour. If the Canadian wage is $30 per hour, should the firm produce in Canada or Mexico, and why? So, we can do a direct productivity comparison in this circumstance. As I said, this is a real question that many organizations face. do a direct productivity comparison. In this case, it makes sense to do productivity measures in units per labor dollar to not only reflect differences in output, but also differences in wage rates. Need common units for valid comparison. So in this case, we do have differences in labor rates, and this is what I wanted to highlight with this example. So Canada $60 units per hour is output. $30 per hour is equal to input. Productivity is equal to 60 divided by 30 is equal to $2, or 2 units per dollar. Mexico, 32 units per hour, 132 pesos per hour divided by 16.5 pesos per dollar is equal to $8 per hour. I'm getting ahead of myself there. And so productivity is equal to 32 over 8 is equal to 4 units per dollar. So while they make fewer units per hour, because we pay them less per labor dollar, they are more productive in Mexico. So on a per labor dollar perspective, Mexico is more productive. But on a labor hour perspective, Mexico is less productive. So based on Mexico is preferred. I will repeat, as I often do, that in this case, as in all cases, the calculations can give us a number, they can give us insight, but they can't give us a decision. So in this case, from a productivity per labor dollar perspective, Mexico is preferred, but there are other considerations that we should think about. And they include material costs, shipping costs, quality, tariffs and taxes, and a variety of other things. So we need to think about the big picture here, and this individual measure gives us one measure that we can use to help us make the decision. As I said, it can't make the decision for us. So this was 4 quick Examples of the types of calculations you might have to do for productivity. We think about we need consistent units. We do it output